Hello and welcome back. I'm Andrei and I'm here with another video. It will be part 2 of our build production grade Clojure application from scratch. Last time we finished with a pretty good state, so we created a really nice foundation for our service. We created it with deps.edn. After that we used component library to manage the state, to stop the system. Also we added a reloaded workflow with a component.repl library, so we can easily refresh our REPL and restart the system without stopping the REPL. So today we will build more on top of that. We will extend our API, we will add component tests for the entire system, and I'm really excited about the video. Let's see what we'll be able to build in this session. So with the magic of editing, see you in the coding session. Okay, cool. So we're back in our editor, and let's quickly review what we have so far. So we have this real-world Clojure API namespace, and after that we have this core.clj namespace as well. So we have the main function, we read the config from IRA, then we have this create system function for the component system, and then we start the system. We have two components. One is example component and one is pedestal component. So inside our pedestal component, we are starting our JT server with some really simple routes so far. That's basically what we created previously. If I execute command 1, you can see here we have this session reloaded, so we have our system started, and if I execute it once again, it's stopping and restarting with the namespace reloading here. Cool. So as today we're going to add more API functions here, like API endpoints. A good thing to start with is actually to think about tests. So first of all, let's create some empty folders for the tests. So we do on the same level as SOC, we do test, and after that, let's split it for now. So we'll say we have our unit tests, and we'll have our component tests. So, and inside both we need to create a package with the name of our service. So it will be a real world Clojure API, Clojure API. Cool. And here we just create a new namespace like API test. Looks good. And we can copy the same here into the unit tests, and let's rename this to like just a simple test. Oh, this is unit. So don't really look into this structure. We will make it better at the end. We just want some framework for now where we can write our simple tests and make sure that everything works. So if we want, we can test that we can actually write a test now. So it's a def test, simple passing test. And let's do 1 to 0, so it fails first. And if I restart the REPL, so yeah, we have the failure, and now if we change it, we'll have a passing test. Also you can see here a green tick. This is working because the cursive by default is searching for tests inside this test namespace. If you don't use cursive but and still want to run tests, your editor potentially supports the same, but also we still need a command to run the tests because we not always want to rely on REPL, so want run command to run our tests before we, for example, push to GitHub. So let's quickly add that, and to do that we'll go to this deps and CLI guide, and then if we go to this simple test runner here, we can use for now the Cognitect test runner. That's not the best thing regarding the test runners available, but for now we just want something really simple so we can execute our tests. But in the further videos we'll have a dedicated session about test runners, and we will compare what options we have. Cool. So moving then to the deps.edn, and we want this alias here. So we'll do test, and we can kill this thing now. As you can see, it's added a test alias, and it specifies like a main options what we want to run, and the function. So now hopefully if we just run command clj-x test, we will have our test runner. Yep, so we have this one test, one assertion, 0 errors. So pretty good. We have a basic test here, and let's move that test here as well. A simple API test, for example, and let's see if that's picked by the test runner. Cool. So two tests, two assertions. That's what we want. The next step is actually let's focus on the tests for our Pedestal service. So a good thing to have an idea of that is if we go to guides section, there is a using Pedestal with component, and for now we can ignore most of that. We'll discuss some things later, but what we're interested in is this macro, which we'll talk about in a sec. So let's put it in our API test namespace. Not the best place to put it here, but as we only have this single namespace for now, we are good to start with like that. But obviously things like that should be split into a shared or like util namespaces later. But yeah, we'll do that. Don't worry. Let's require the component start. So you don't have to be a macro expert here. I'm not a macro expert, even I'm working with Clojure for 7 years, but it's pretty simple. We basically will have our system, and this macro will start the system, then execute the body of the test, and then finally stop the system. Even if there was an exception, this is finally blocked, so it will be executed anyway. So regarding the usage of that, let's copy this one, this example, and as we have this greeting API, we can keep the test name like that. So instead of this new system, we want our core namespace now available. So it will be a real world Clojure API core, AS core, because it has the function to create the system. So it will be core, real world, and then we have to pass a bit of configuration. So it will be server port, and let's just put whatever port we want now here. Cool. So let's just add a super simple assertion here that's actually doing nothing with the system itself, and we'll try to execute this function. So even the assertion isn't doing much with the system, we still see now that it's starting and stopping our test system because we have these print lines. So that's pretty cool. Actually, the next step, what we want to do with our system is execute a real HTTP request. And for that, we will need an HTTP client library. So let's go to CLJ HTTP, and we click on these closures and get the dependency. Going back to deps.edn, put here, and we have to restart the REPL. Going back to our API test, and we can include it now here as client. Cool. So after that, we want to do a real call. So let's compare it with something. So it fails, but we have the diff after that. So it will be client get, because we want a get request. Then we have HTTP localhost, and we want our port here, and we want to wrap it in a string, and we want greet at the end. Cool, it's failing, but we now can see that our actual value is actually a body returned from our system under the test. And we want to make this assertion passing by doing, so we want to check the body will be hello world, and the status will be 200. And here we can do select keys, and we want body and status. And let's put this URL as the first thing in the threading macro. Let's test. Cool, that works. So we already done pretty cool things. So in the test, reliably, we can create this SUT, which stands for system under test. And after that, inside this macro, inside this body, we have actually our system running. So we have a real HTTP server, and we can write a component test on top of that. So we will make a real request here, and we'll get a result. So we can create assertions, which is pretty cool. So moving next, let's actually add some new endpoints to our Pedestal routes. So to do that, we will use this guide, your first API, and we need a couple things first. So we'll have this OK response utility function first here. Let's make it a bit prettier. So we don't care about the headers for now. So let's say it's just nil, or yeah, like that. We'll touch these headers later when we will work with the content negotiation, but that potentially will be in the next series. Cool. So we have this OK response, and we want an extra route. So we will create this to-do list API, and let's pick this one for now, and let's put it into the route table that we have. So for the echo handler, let's use this echo as a base, but we'll change it to something else. So let's call this one get to-do. So the to-do will return by ID. So, and this one I prefer just to call to-do ID, so it makes more sense to me. So instead of this echo handler, we want really get to-do handler, like that, and we want to put it here instead of echo. And we're using this OK response here, as you can see. For now, it's not doing much. We're just returning the entire context as we received it into the response. That will be pretty useful for debugging for now, but yeah, we'll see. Cool. So as we added extra things here, let's go back to our tests and let's copy this entire test, and we will call it get to do test. So we will create a to do ID first, and it will be a random UID. And after that, here we will call to do, and we want to put now this to do ID as the part of that. So let's see what we have back. Cool. So as expected, this is like echo response handler, and we get a lot of information here inside the body. So let's work with that. So first of all, let's design how we will store our to-dos in memory. So as we don't have a database persistence layer, we will not use database for now. We'll just use an atom that will be a part of our system state, and this handler will basically use this atom to get information we need. So let's model that first. Let's say we have this comment section so we can put some things inside. So it will be a list of to-dos, and each to-do will have an ID. So it will be a random UID. And then we have a name, my to-do list. And then we will have items, and it will be a vector as well. Inside items we'll have item ID, which will be a random UID, and maybe like a name as well, or something, like make a new YouTube video. And then we have, for example, status created, something like that. And we can have multiple to-dos like that. So the other one, for example, empty to-do list, and it will basically have 0 items inside. So we want our data structure to look something like that, right? But I don't really want to put it as a part of the Pedestal component. Plus, let's refresh our knowledge about the component system. So we will use this example component, and we just copy it to a new namespace. Let's call it in memory state component. Cool. Now we need to replace a couple things. So it will be in memory state component. And we want to rename this one as well. In memory state component. Right, cool. What we want here is we want something like a state atom, and we'll create a new atom with an empty vector on the start, and on the stop we'll just set this atom to nil. Pretty basic. If we go back to our core, now we want to add a new component in our system. So it will be in memory state component. Cool. And an extra require here, in memory state component as in memory state component, right? So we can now use this. It will be new in memory state component, and now we want to link it to our Pedestal component. So we just a refresher, we're using this component using, so we create a component but also passing the vector of dependencies. So now in this Pedestal component right here, we will have the access to our in-memory state component. Cool. And what it will allow us to do is actually to add an interceptor that will pass our dependencies inside the context of the handler. So we want our in-memory state component available here in the context of the request. So we can use that to get our information. So we want to search for to do by ID. So I want to do it here. And the same approach will be with the database connection pool. So if you want to do a query to the database, we want database connections available on this level. But for now, let's focus on this simple in-memory state. Yeah, by the way, I just restarted our system, and we can see now that it's already also starting this in-memory state component. And if I do once again, we see it stopped and then started. Cool. So now we want to look into interceptors a bit. And the concept is pretty simple. So we have this context map that basically initially just describes our HTTP request that we receive from JT, and after that it comes through the pedestal abstraction. So we have our HTTP request that we received in a nice format of a Clojure map. And after that we have the chain of interceptors that they have enter and leave stages. So when the context map comes from the request to the handler, we pass it through the chain of interceptors with the enter function, and on the way back it goes through this leave function. So we can add extra things, we can add extra logic inside interceptors that are common between requests, and we will use that to inject our dependencies into our context. Let me show how to do that. So first of all, let's create our interceptor. So we'll call it Inject dependencies. And then we have this interceptor helper. And I think it has the name and enter here. So this will be a function, and we'll have the context here. But we also want to make this a function as well. So we will have dependencies on this level. And then the name will be Inject dependencies. And the only thing we want to do in the context is sock our dependencies inside the context. Dependencies. Cool. So after that, we want to keep our default interceptors that Pedestal provides. So we can do it by calling this default interceptors on top of this map. Just remember that on this level, we're just working with a plain Clojure map describing some options. But it's useful because if we go inside this function, we can see there are some interceptors that are added by default with this true here. For example, for the query params, for the method param name and all that stuff. So we'll have a better representation of our request when we do the logic in the handler, because it passes through this default interceptor chain. But after that, as we still have a plain map, we can do update here, and we will use this HTTP interceptors. And what we want to do is concat our new interceptor inside. So it will be inject dependencies. And here we basically want to use the entire component as our dependencies. Cool. So yeah, that looks good. let's restart. Yeah, it still works. And now let's go back here, and we will print the keys. Let's say we are inside this get to do handler, and we also will print keys of the context. Cool, I've spent a bit of time trying to understand what was wrong, but actually it was a super stupid typo. It's not key, but keys, to get the keys. And now we have our tests working again. It's obviously failing, but it's failing in correct way. So we have the response from there. And also we have this print line here, which will show our keys, right? So we'll see this thing, but what we're interested in is these dependencies. So it's what added by our interceptor that we added in this component right here. So the good thing is that we now have access to the in-memory state component. So usually we can do something like keys and then dependencies, and but we still want to name it as context. And after that, keys, and after that we can do let, and we maybe we'll actually pass the dependencies to the function. So now let's create a function to get to do by ID, and what we'll do is we'll pass dependencies here, but we can destructure our in-memory component state component here. Why I'm doing so many typos today? Cool, keys. And after that, let's search by ID. So let's say we'll have to do ID here, and we want something like we want our state atom derived. So we want state atom from in-memory component. After that we do filter, and this will be a to do, and we want to search for a specific ID. So it will be to do ID equals to ID from to do, and we want first. A pretty naive implementation, but that will work for our purpose for now. So having that, now instead of returning the full context here, we actually want to return a meaningful result. So we want to pass dependency now. So inside dependency, we'll have this key for the component because we're passing that inside our pedestal component. And after that, we want ID. And for ID, it will be request path params and then to do ID. It is basically is coming from this definition. So if we have this named like that, it will parse this path params and name it like that. So yeah, the only thing we want is, as it will come as a string, and we decided to put IDs as UIDs. We want to pass UID from a string. Cool. Cool, let's see what we have if we run the test now. Yeah, we have this empty string because we don't have any to-dos in our atom. So to fix the test, we can prepare some state before calling that. So we can do, as we have this system under test here available, we can basically do a reset on the atom. So it will be system under test, and then we have our in-memory component, and then we have our state atom. And we can put a list here. Let's rename this one to do ID 1, and we will have to do 1, and it will be a map of ID, and ID will be to do ID 1, and the name will be my to do for test, and then we'll have, for example, a list, how we called it, items, right? Items, and like ID, random ID, name, finish the test. Something like that for now. We want to reset it, reset our state before we run the test to this vector of to-dos. So if we run now, we will see that we actually have this thing, right? So now we want this to be string of our to-do 1, to do 1, and let's see. Yeah, now we have a passing test. Just to add an extra assertion, we can do is equal to and then we want the same block from here, but now instead of to do ID 1, we want to pass a random UID, and let's actually name this. So we're testing that empty body is returned for random to do ID. Cool. Let's see. So yeah, it should fail because we have a wrong assertion. But now if we do empty string here, the test is now passing. Cool. Let's check if our test's passing in the with the CLI command as well. Yeah, 4 tests, 5 assertions, all good. So it was basically about the passing the dependency inside this handler. By the way, we forgot to rename this one just for readability, and we can remove this thing. So it will be get to do handler example. Cool. Yeah, so a couple things to improve in our tests. First of all, this building of the URLs is looking a bit hacky, so we can improve that. And luckily, Pedestal provides some useful functions for that. So we use this one, and we go to our Pedestal component. We go to the roots, and we can set here. This will be roots. So it will create this function for us, URL4. And now let's first test it in our unit tests. So we can do Pedestal component, and we can refer this URL, URL 4, right? Yeah, URL 4. And now let's create a new test, URL 4 test. And first case will be testing greeting, greet endpoint URL. So what we can do now is we can use this URL for function to construct the URL from the name of the resource. So let's compare it to an empty string for now, but we can do URL for, and then we pass the name of the resource, which is greet for this root name we're interested in. And going back to our test, let's see. Yeah, this should be greet now because this is returning correct thing. But it's not too impressive now. But if we do the same for our path params, so it will be get to do by ID endpoint URL, and now we want to generate the to do ID first, random UID, and then we want it to be get to do, and we set path params to, and we have our to do ID here, to do ID. Let's see. Yeah, so now we want this as our expected thing. So we can change this to do combined with our to do ID. Yeah, tests are passing, cool. But the good thing is now we can add, we can use this function here to easily construct our URLs. So the other good helper function I can think about is something like defen system under test to URL. And what we will have is our system under test and then the path. And after that we will do a string join, and we will have our HTTP local host, and then we'll have the port, but we can get it from the system under test. So we do pedestal component and then config server port, and we want to add the path at the end. Cool. So if we go down here, so let's start with the greet test first because it's easier. Oops. Let's move it above the test. So instead of doing this manually here, we can now create the URL from system under test, and we're passing the system here, and after that we do our URL for call. So it will be pedestal component refer URL for, and yeah, so it will be URL for greet. Let's first of all check that this is correct URL, and we can do it by just comparing it to something. Let's see. Yep, the URL is correct. And if we remove this, now we have a working test, but this looks much better because we don't have to care about this URL construction anymore. So let's rewrite these two things to the same approach. So it will be system to URL, and then we pass the system, and the path will be URL for get to do, right? To do, and we pathing the path params, and we're passing to do ID. To do ID 1. That's it. Let's check that it's working. Yeah. And we want the same in the second call, but it was a random UID. Yep, cool. And the final improvement for today will be to get rid of these static ports that we putting here in our test configuration. In our simple case, that works, but if we have multiple namespaces here and we potentially eventually want to run them in parallel, this will be a problem, because if you're unlucky, two tests are running in the same time, you try to create a server on a real port twice, you get the address socket is already used exception and your test is failing, which is not great. So it's much better to generate a random port, and we also, to construct the URL, we're just getting it from system under the test anyway, so we don't have to pass it anywhere else. So to do that, let's create a simple help function again. So let's call it get free port, and we can do it with open, and then we have our socket, and there is a server socket, and if you pass 0 there, and if we check docs, it says 0 means the port is automatically allocated what we want, and we want to close the socket, and this is basically handled with this with open, but the only thing we want is get local port from the socket. So now we have this function that creates a random port for us, and now let's replace this one with a function call. And where is the other one? Cool. So let's see, still works. And just to prove that it's working, let's compare this URL once again to something. And as you can see, it's no more our hard-coded code, but it's actually a random port free on our system at the point of time. So yeah, that's it. Let's double check that our tests are still passing. Yeah, looks good. So that's it for this part 2. In the part 3, I think we'll take a look into adding more routes from this list. So we'll do post, we'll do put, we'll do update to see how that works. Plus, potentially you noticed that the response type here is just a plain string, and inside we have like a EDN to string, which is not what we want in the real services. So we will take a look into content negotiation as well. So we want our service to be able to communicate with JSON. So yeah, that's on the list. And also I think in the next video we'll take a look into how to add schema validation on top of the requests that we receive. For example, when we will create this to-do item, we want the body to be valid across a to-do item spec. Right, so that's the end for the video for today. I really appreciate that you watched it until this point, and the best support for the channel will be your comment, your like, and your subscribe. So that really helps, as I just started, and it really motivates, so don't mind doing that. And also just tell me about yourself in the comments. Are you using Clojure in production, or you just started learning? I'm really interested into that as well. Also, any questions, feel free to ask them in the comment section below as well. Cool. So pretty good progress today. More videos in this series will come really soon. So I hope it's useful for you. And yeah, happy coding. Have a lovely day and see you in the next video. Bye bye.